Hi everyone, I'm Sang Kim. In this video, I would like to share how to do stepwise regression analysis in R and interpret the output in Excel. In the previous video, I showed you how to do multiple regression analysis in Excel and R. Considering p-value, we can say that x1 variable is significant and other variables are not significant under 5% significance level. So it means that we need to select some variables in order to find out better multiple regression model. In multiple regression analysis, three methods such as forward, backward, and stepwise are very popular to select meaningful variables. As you can see, we can do stepwise method by step function in R, and our output shows you step-by-step progress. There are 1, 2, 3, 4, 5. 5 steps in this case. The final step shows x1 plus x3 regression model is better than any other models from AIC standpoint. In this video, I would like to show you how to calculate AIC from full model, which is same as non-model. And also would like to show you how we can get sum of square and residual sum of square and AIC once we drop x5 variable. Okay, I initially set up regression coefficients as 0 to get maximum likelihood estimate. So y hat can be calculated by b0 plus b1 times x1 plus b2 times x2 plus b3 times x3 plus b4 times x4 plus b5 times x5 times plus b6 times x6. Okay. Then y minus y hat squared can be calculated by this formula. Okay. Then log likelihood, we can use this formula. So we need to estimate sigma squared and beta 0 and beta 1. So sigma squared can be estimated by sigma hat square from this formula. So from sample data. So sigma hat square can be calculated by sum of y minus y hat square here over 3. Right. Log likelihood minus n over 2 equals 15 times log of 2 times pi minus 15 times log of sigma hat square minus sum of y minus y hat square over 2 times sigma hat square. Right, then click solver, changing values from b0 to b6, and objective is log likelihood. Right, this is estimated regression coefficients from maximum likelihood method. Right. So log likelihood is same as our output, and AIC can be calculated by minus 2 times log likelihood plus 2 times number of parameters. There are 7 regression parameters and sigma, so 8 parameters. Right, this is AIC and is same as our output. But as you can see, stepwise AIC is a little bit different because it uses this formula. So 30 times log of sigma hat square plus 2 times number of regression coefficients, so 7. Right, this is same as this one and full model. So in stepwise regression, we started full model. We want to reduce AIC. So once we drop X5 variables, it has smallest AIC, right? So let's move on when we drop X5 variables. Again, so y hats can be calculated by B0 plus B1 times X1 plus B2 times X2 plus B3 times X3 plus B4 times X4 plus, there's no X5 variable, yeah, and B6 times X6. Okay, and y minus y hat square then again sigma hat square sum of y minus y hat squared over 3, right, and log likelihood minus 15 times log of 2 times pi and minus 15 times log of sigma hat square minus sum of y minus y hat square over 2 times sigma hat square. Right, then also let's use solver here. Right, log likelihood is same as this one. So we were able to get regression coefficients from maximum likelihood estimate. Then AIC can be calculated by minus 2 times log likelihood plus 2 times number of parameters. So 6 regression coefficients and sigma, so 7. Right. So AIC is the same as our output. Right. Then let's see when we drop X5 variable. Okay. So first, let me show you how we can get AIC first. This one. So 30 times log of sigma hat square plus 2 times number of regression coefficients, so 6. Right, this one. Then let's get ANOVA table. So click data analysis, regression, Y range, select A column, column A, and input X range from column B to column F. And check labels because there is for a variable name in the first row. Let's see the output here. Right. This is residual mean square of residual. Let's see from full model. This is residual mean square from full model. Okay, and sum of square. This one. Okay. Right. Then sum of square, once we drop X5 variable, can be calculated by 3.41. So we from ANOVA table we were able to get sum of square, residual sum of square, and we also know sum of square, residual sum of square from full model. So this is the difference between full model and reduced model, right? And residual sum of square is this one. Okay, so from let's say a start point. So as I explained, when we consider 6 variables as full model, there is AIC. But as you can see, R considers how AIC is changing once we drop x5 variable, x4 variable, x2 variable. So it shows that once we drop x5 variable, it has a smallest AIC. Then in the next step, non-model is same as this one, right? So it excluded x5 variable. Okay, so it also shows that once we add x5 variable, how AIC is changing. So this is same as full model, right? So in this process, as I explained, stepwise regression method finds out the best model. So according to this analysis, we can say that x1 plus x3 is better than full model and other models, yeah, from AIC standpoint. So considering x1, x3 variable as multiple regression model, then x1 variable is significant, but still x3 variable is not significant under 5% significance level. But from AIC standpoint, this model is better than other models. That's it for today. I hope it was useful for you to understand how we can do stepwise multiple regression analysis in R. And you understood the concept of stepwise regression. Please click like and subscribe if it was useful for you. Thank you.